All right, for this problem, we're asked to find the point on this sphere, x squared plus y squared plus z squared equals 4, that is farthest away from the point 3, 1, negative 1. And so the way that we're going to do this, we're going to use Lagrange multipliers, and we're going to imagine this point as being the center of a sphere. And we're going to just keep expanding that sphere as far as we can go. And the farthest point that we can expand that sphere that's still going to be on this, touching this sphere, that's going to be the point that's farthest away from this center point. So our function f of x, y, z is going to be equal to the sphere that's centered at this point. So that's going to be x minus 3 squared plus y minus 1 squared plus z plus 1 squared. So there's our function. This is our f of x, y, z. This is going to be our g, set that equal to 0. And that's going to be our g. And we know that the gradient of f has got to be equal to the gradient of g times some lambda. All right, so the gradient of f here is going to be 2x minus 6 times our unit vector I plus 2y minus 2 times j plus 2z plus 2 times k. All right, and so if let's go ahead and put our gradient of g here. That's going to be 2xi plus 2yj plus 2zk. All right, and so this has got to be equal to this times lambda. So we get 2x minus 6 is equal to 2x lambda. And so let's solve for lambda. If we divide both sides by 2x, we're going to get that lambda is going to be equal to 2x minus 6 divided by 2x is going to be x minus 3 divided by x. Now let's use that lambda up here. So we got 2y minus 2 is equal to 2y lambda. If we plug in this value for lambda, we're going to get that 2y minus 2 is equal to 2y times x. So 2xy minus 6y divided by x. And then if we multiply both sides by x, we're going to get 2xy minus 2x, that should be an x, is equal to 2xy minus 6y. So if we subtract 2xy from both sides, we're going to get that negative 2x is equal to negative 6. Divided by negative 2, we get that x is equal to 3y. All right, over here with z, we're going to do the same thing. First, we've got 2z plus 2 is equal to 2z lambda. And then if we solve for lambda, we're going to get that lambda is equal to 2z plus 2 divided by 2z is going to be z plus 1 over z. And then plugging that into this, into this equation, plugging that in for lambda, we're going to get that 2, we're going to multiply by z, so 2yz minus 2z is going to be equal to 2y times z plus 1, so 2yz plus 2y. And again, if we subtract 2yz from both sides, we get negative 2yz equals positive 2y, so z is going to be equal to negative y. So now these two equations, y equals 3y and z equals negative y, are going to be the important points that we need to solve the rest of this. So let's erase everything but those points. We found this information that we need. Now this is x equals 3y, z equals negative y. Let's go ahead and plug that back up in here into our constraint. So if we plug 3y in for x, we get 3y squared plus y squared plus negative y for z. So negative y squared equals 4. So this is 9y squared plus y squared plus y squared is 11y squared equals 4. So y is going to be equal to plus or minus 2 over the square root of 11. We divide both sides by 11 and then take the square root of both sides. And now x is going to be 3 times this, so x is plus or minus 6 over the square root of 11. And z is going to be the opposite of this, so z is also going to be plus or minus 2 over the square root of 11. All right, so now we've found our 3 points. Now, we got to figure out, do we want positive or negative for each one of these? Well, we're trying to find the point that's farthest away from an x coordinate of 3. That's going to be negative 6 over square root of 11. And the point farthest away from positive 1 is going to be negative 2 over square root of 11. And the point that's farthest away from negative 1 is going to be positive 2 over square root of 11. So that's going to be our answer. That's the point on this sphere that's farthest away from the point 3, 1, negative 1.